today our plan is just to go through integration by substitution. Now this is a very clever process that we can use for performing some integrals of complex functions. And we're just going to leap straight into the process as it's a process that we're learning here, not a rule as such, not a formula. So what we're going to do here, right, we've got this integral statement. And what I'm going to do is I'm going to let u be this function here, this composite function. So we have x to the 4 plus 3x squared. All right? Now, if that's our u, then du with regards to dx, if we differentiate this with regards to x, we would have 4x to the power of 3 plus 6x. So now I'm going to rewrite this statement in terms of these parts. All right? So this integral statement, what it becomes is the integral of u to the power of 7 multiplied by du on dx. All right, that's du on dx, and then we have multiplied by dx. All right, everyone okay with that part? So there's u, there's 7, there's du on dx, and there's the dx. Now du on dx multiplied by dx, so the same thing at the bottom and top, so that will cancel. And what are we left with? The integral of u to the power of 7 with regards to u. Okay, so that's something we can perform, isn't it? What does that become? U to the 8 on 8 plus c. And then we will substitute u back in. Okay, so, okay process, but you're probably going, how do I know which one to be u? All right? How do I know which one to be u? And it'll become more evident the more we do, but what we're doing is like, one of them's the derivative, one of them's the original function. Which one's the original function? Over in B, we're going to let u be sine of x. So therefore, du on dx will be cos of x, because that's what it is. And so our integral statement becomes u to the power of 5 du on dx multiplied by dx. The dx cancels. U to the 6 on top of 6 plus c. So what's u sine of x? 1 on 6 sine to the power of 6 of x plus c. Okay. Yeah, a little bit more tricky. On to C. We're going to let u be 5 take 4 x squared. Alright, so therefore du on dx is going to equal minus 8x. Alright, so this one's not a straightforward substitution. What we can do, alright, I want to manipulate this so that we have something like this, right? E to the u du. That's what I want it to be. E to the u du. At the moment, we've got x here, but we don't have minus 8x. So one way we could change it, alright, if we think of du on dx, if you multiply it by 1 on 8, negative 1 on 8, then that's when it's going to become positive x, isn't it? Okay? So really what we've got here, if we're thinking of this expression, is we've got the integral of, well, let's do this front part first. It's minus 1 on 8 lots of du on dx. That's what we have at the front here. Minus 1 on 8 times du on dx will give you positive x. We have e to the power of u, and then we have dx. Alright. Minus 1 on 8, I'm going to bring that out the front. And what are we left with? E to the u du. Integral of e to the u is going to be e to the u plus c. So we have minus 1 on 8 multiplied by what is the u, 5 take 4 squared, plus c. Okay, again, how can we check? If we differentiate this, what do we obtain? We're going to obtain that one there, what we started with. Alright, on to D. We have 2x plus 5 on x squared plus 5x. So if we let u be the bottom function here, alright, then du on dx is going to be 2x plus 5. Okay, so our integral statement becomes, I'm going to write it like this, the integral of 1 on u multiplied by du on dx multiplied by dx. So it's the integral of 1 on u with regards to u, and this becomes ln modulus of u plus c. Right, substitute u back in, not brackets, modulus, sorry, x squared plus 5x plus c. Let's do this one right. Okay, this one requires a little bit of manipulation. It's not one that's immediately obvious, but when you do a few problems that are similar to this, you'll start to notice what's going on. Now, one thing we can notice about this is we've got sine to the power of 3x, and the first thing we're going to do is replace that with 1 take cos squared of x times sine squared of x. Okay? 1 take cos squared will be sine squared. And then when we multiply sine squared x by sine x, we get sine to the power of 3x. Okay? Alright. So this one, not something that's obvious, right? Something that one way we have to manipulate. Now what we're going to do is we're going to distribute this cos to the power of 4x into this bracket. So what we'll be left with is we'll have cos to the power of 4x, take cos to the power of 6x, and then we have this sine x with regards to dx out in front of the bracket. Okay. Alright, now we can let u be cos of x. And so du on dx will be negative sine of x. Okay, so now if we want to write this integral statement in terms of u, what it's going to be, it's going to be the integral of u to the 4, take u to the 6, and then over here we've got negative du on dx, right? Positive sine of x, we need to have negative to make it positive, and then we have dx. Dx will cancel, the negative can come out the front, and we have the integral of u to the 4, take u to the 6, that's u to the 5 on 5, take u to the 7 on 7, plus c, and we'll substitute u back in. We're going to have cos to the 7x on 7, take cos to the 5x on 5, plus c. So I've distributed that negative and substituted cos of x back in.
Mr. Ross.
Yeah.
What happens to the minus du?
Oh, that negative went there. So
Okay.
it's like a number that I can pull out the front. Remember, it's just minus 1, isn't it? So when we have a product of an integral, one of the properties, integral of kx, we can pull k out the front. Yep, so that's hanging out there. And then I distribute it.
Okay.
I mean, you can just chuck it in here as well. Okay, last one. This is the last one, right? For you guys, I need to get update my booklet. We've got cos of x times the square root of sine x. So what we're going to do is we're going to let u be sine of x. And now du on dx will be cos of x. So what we have is the integral of 1 on the square root of u du. Alright, so it's not necessary to write du on dx times dx. We can just jump straight to this statement. And I'll process this one a bit slowly. We've got u to the negative
What is influence? Basket.
minus half. I'm differentiating there. U to the minus half plus 1 on top of minus half plus 1 plus c. So what have we got? U to the positive half on top of half plus c. Right my answer. I'll go next to it. So that's going to be 2. Now u is sine of x plus c. Alright, so that's integration by substitution. So you can see it's quite a clever process. Now it's a long exercise, but it takes you through all these sort of examples that we've done. So all the examples touch on different points of the exercise, and it's a skill that you've developed throughout the exercise. So yeah, good luck.